In this video, we're going to take a look at testing the difference between the fares between the three classes. Now, we already took a look at this variable when we were trying to decide how to summarize it, and we went with the median and the interquartile range. So we would do a non-parametric test to go with this. If we're going to describe it with the median, then we want to use a test which is relevant to that. However, I thought it might be useful just to look at the means and what we would get if we ran an ANOVA just by comparison. So we do actually have a reasonably large sample size here. So you could argue that the central limit theorem applies and that it would be okay to test the means. And in general, I wouldn't really have a problem with this. The only thing is, because of the outliers, the means are really inflating where the middle is. So the outliers pull on the mean and they pull it upwards so that the center of it, if we're using the mean as the measure of the center of the distribution, can look higher than it might otherwise. So if we have a look at the means here, we can see that the first class mean was 87 pounds, but the median, the middle fare, was 60 pounds. So that's quite an inflation of like halfway through this quartile. So the median is a more stable measure. However, if you ran the test on the means, you would actually you'll get a significant result basically either way, just because the difference is so enormous. And that happens a lot in statistics, that when you've got a really large obvious difference, it almost doesn't matter which way you test it because it's so big, it's going to show up in everything. So if we are testing the means, I'll just stick with this one here. I'll go down and we can see this with the error bar chart. We can see that there is a massive difference between first class and second class. And there's also a reasonable difference between second class and third class. And we can see that the confidence intervals do not overlap at all. So we are going to get a significant difference here. Now, just as a point of clarification, you can actually have a tiny overlap of the confidence intervals and still get a significant difference. So don't assume that because confidence intervals overlap that you won't get a significant difference. It's a little bit confusing, and it has to do with the maths of how the whole 5% thing works. But if there's no overlap of the confidence intervals, you're definitely going to get a difference. And we can see it's absolutely enormous here. The only, I guess, issue might be is that this might be inflated, in that it might look bigger perhaps than it really is, just because of these absolutely extreme outliers. I'm just going to call these the presidential passengers because they're clearly paying a lot more than everybody else. So if we ran this as an analysis of variance, and let's go ahead and do that just so we can make that comparison. So compare means, we've got three groups, so we can't use a t-test. We'll have to use the one-way ANOVA. We're looking at the fare and the passenger class. And I chose the Games HAL comparisons just because I'm not going to assume equal variances, just because there's a whole lot of stuff going on. But there's a whole bunch of these you can choose. I'm pretty sure whichever one you go will be significant. And you could read more about these online if you want to check you're getting absolutely the best one for your particular situation. So if I run this, overall, we've got very strong evidence that the means are not equal for each of the passenger classes. This doesn't tell us where the differences are, which is why we want those multiple comparisons. And we can see that there is, you need that yellow box to go away. There is a significant difference between first class and second class, first class and third class, and so on. So the difference between first class and second class on average is 66 pounds, which is quite a lot. And you can see that that is actually bigger than the difference between the medians here. So that's why we would want to be a little bit careful in reporting these, because it might make the differences look exaggerated. Now, the reason that the ANOVA is helpful and looking at the means is helpful is because it's really easy to say what the difference is. Whereas when we start doing the non-parametric tests, what we're actually working with is ranking all these fares. So we get all the fares together and we rank them from most expensive down to the least expensive. And then we're looking at the mean rank rather than the actual mean. And so all of a sudden, the number we assign to it isn't very intuitive. So what we would do if we were reporting this with a non-parametric test is we would give the p-value from the non-parametric test, but then rather than describing the mean ranks of the 1,300 passengers ranked most expensive to least expensive, we would probably just talk about the medians because it makes more sense. And we might even talk about the maximum ones just out of interest because it's so curious. So if we want to run this as a non-parametric test, we would go down here, non-parametric, independent samples. Our test field is fair. We're looking at passenger class, and you can see you've got some options here that you can go into if you want to. Highly significant p-value. Then if we want to look at which groups are different from each other, we get these pairwise comparisons where we're seeing third class is different from second class, third class is different from first class, and second class is different from first class. And then they always give us this diagram, and I guess sometimes it's helpful. I don't really find it that intuitive, but maybe someone can tell me a different way to look at it so it feels more intuitive. So this is where we've got the mean rank of the passenger class. So if we rank all our passengers from paid the most to paid the least, the mean rank is over 1,000 for the first class passengers. So they're all up in the paid the most kind of category. And then the mean rank of the second class is down around the 700. The mean rank of the third class is down around the 400. So that's how we would interpret that. But really what we're interested in is this p-value here. I'm assuming it's quite small. Usually, is it not going to give me the exact number if I hover over? E to the 0? Okay. I'm just going to assume that that is less than 0.001. I'll just put the 2 zeros in because I can't actually see what's happening past those three zeros. And then when I'm describing this in the paragraph, I would talk about this difference, and maybe I would even include a chart because it's quite interesting. The only other thing I would say here is that in this case, we have 3 groups, and in each case, we've found that each group is different from the next one. But if you had a situation where the first class paid more, but there was no difference between the second and the third class, because the difference here really is much smaller than it is between the first class and the second class, that's where you might want to actually use more superscripts. So you might put in, and let's say an A here, and then each of these, if these were not significantly different from each other, might give them both a B, and then we would need to put a little footnote explaining that. Now, this is not the only way to add in superscripts to illustrate that groups are different from each other. And I have actually seen in some papers where they do the opposite of this, and groups which I can't even think the opposite way around. So here I've got a different letter for groups which are significantly different, and I have seen a paper which does groups that have a different letter are the same. I can't remember. It was very confusing. Anyway, so what I would recommend is that you have a look at the way multiple comparisons are reported in a paper that's of your discipline. This is, I think, the easiest way to do it, where letters which are the same are not significantly different from each other. And then you can go, all right, A is different to B, but the two Bs are not different from each other. But in this case, they are all different from each other. So we would actually give that a different letter, C. And each of these is different from each other, no matter which way we look at it, which is quite nice. So this is perhaps an unusual situation where we've got such huge differences that everything is popping up as significant, which is part of the reason why I might be inclined not to even include these tests and just describe it because it's so obvious. But you can have a think about whether you need it for your particular situation. Make sure that you include all the relevant information on the table. So this is, I would need to add another line for the A, B, and C, and write a little description about what those mean. That's accidentally capitalized. And actually, I could probably put that just after the Kruskal-Wallis test, put it on the same line, save a bit of space. And then in the next video, we'll move on to talking about choosing a technique for our our main analysis. So this is, we're finally getting up to the main thing we were interested in, and there's just all these steps we need to go through along the way.